Rectangles could sometimes be a square. Okay. What else could sometimes be a square? The parallelogram could sometimes be a square. So orange and green, orange and green. They don't have to be a square, but they could be a square, right? Why is that true? Well, because remember that a square comes from, first of all, a rectangle, but the rectangle comes from a parallelogram. So they kind of all, think of those little like Russian nesting dolls. They kind of all fit into each other. All right. So hit next. So here's the lesson for today. Here's what we're going to do. Today we will classify quadrilaterals in the coordinate plane using distance formula, slope, and the diagonals. Okay? So I'm going to do the first 5 or 6 tiles with you, and I'm going to show all of my work for anyone who's not here. But once I get to tile 8 and we're done, you guys are going to have to get a dry erase board and do this on your own. You're going to have to finish it. So make sure you follow along. So we're looking at this shape, this quadrilateral over here on the left. Everybody sees it and asks us to find the slope of line AB. Well, you know what? I can just count that. The slope of line AB, it looks like I go up 1 and to the right, 2, 4, 6, 8, 10. So the slope of line AB is 1/10. What about the slope of line BC? Well, let's see. I have to go from C to B, so I go up 1, 2, 3, 4, 5, to the right 2. So the slope of BC is 5/2. What about the slope of CD? Let's see, from D to C, I go up 1 and to the right 10. So this has a slope of 1/10. And then the slope of DA, from D to A, I go up 5 and to the right 2. So this also has a slope of 5/2. Okay. So it says, first of all, check my work. Did I do that right? So I'm going to check. I should have all thumbs up. Everybody got that? Is yours in there yet, Andrew? Okay. So we should have all thumbs up. Are there any parallel sides? Are there any sides that have the same slope? Which ones? There are 2 sets. BC and DA are parallel to each other, and AB and CD. So you have 2 sets of parallel sides. That means this is a parallelogram. Are there any perpendicular sides? Yes or no? No, there aren't. Are there any opposite reciprocal slopes? No, there are not. There are no opposite reciprocal slopes. So press no on that one. I don't know why it's not letting me. There we go. And hit next. So now it's asking me to find the length of AB. How do we find the length of a segment? Well, yeah, we have to use the distance formula, or we can use Pythagorean theorem. And some of you guys are really struggling with the distance formula. So I'm going to draw a right triangle. So I'm trying to find the distance from A to B. So this first leg has a measure of 1. The second leg has a measure of 10. And I'm trying to figure out what C is. Pythagorean theorem, 1 squared plus 10 squared equals C squared. What is 1 squared? And what is 10 squared? 10 squared is 100 equals C squared. What is 1 plus 100? It's 101. So 101 equals C squared. How do I get C all by itself? You have to take the square root of both sides. So C equals the square root of 101. That is the length of this side. The square root it's It's really hard to get that symbol. The square root of 101. Okay. Now I have to find the length of side BC. So for BC, I'm going to use the distance formula. BC. I'm going to use the distance formula. So that means I'm going to find the difference of the x coordinates, 5 minus 3. And then I have to square it. Plus the difference of the y coordinates, 1 minus negative 4. 1 minus negative 4. Well, 5 minus 3 is what? That is 2. So I have 2 squared plus, what's 1 plus 4? 5 squared. Okay. What is 2 squared? And what's 5 squared? So what is the distance of B to C? It's not 29, it's the square root of 29. So the distance of B to C is the square root of 29. Okay. Now I have to find the length of side CD. CD. I'm going to use the distance formula again. I'm going to take the x coordinates and subtract them. 3 minus a negative 7. 3 minus a negative 7, the quantity squared, plus the difference of the y coordinates. Negative 4 minus a negative 5, the quantity squared. What is 3 plus 7? That's 10, so that gives me 10 squared. What is a negative 4 plus 5? 1, that gives me 1 squared. What is 10 squared? Plus 1 is the square root of 101. That's the same thing that we got when we used the Pythagorean theorem. I want you to use whatever method works best for your brain. Okay, whatever method works best for your brain. 101. So the last one, segment AD, I'm going to use Pythagorean theorem again. So I'm going to draw my triangle. So this leg is 5, this leg is 2, and I'm going to call this C. So 5 squared plus 2 squared equals C squared. Well, 5 squared is 25, and 2 squared is 4 equals C squared. 25 plus 4 is 29. How do I get C all by itself? How do I unsquare it? Take the square root of it. So C equals the square root of 29. That means that AD is the square root of 29. And it says, check my work. You should have thumbs up on everything. Check my work. You should have all thumbs up. Are there any congruent sides? Sides that have the same length? Yeah, there are 2 sets of opposite sides that are congruent. Absolutely. Hit the next one. Now it's asking us to do some things with our diagonal. Well, you know what? We don't have any diagonals drawn in here, so I'm going to draw them. This is diagonal DB. It helps me to see it. And this is diagonal AC. So I need to find the length of diagonal AC. The length of diagonal AC. So let's see. Negative 5 minus 3. Those are my x's. The quantity squared. Y's. 0 minus negative 4. 0 minus negative 4. So what is negative 5 minus 3? That's negative 8. So I have negative 8, the quantity squared. And 0 plus 4 is just that. 4. Well, what is negative 8, the quantity squared? That's 64. And 4 squared is 16. What is 64 plus 16? It's 80. So the length of AC is the square root of 80. The square root of 80. Now we have to find the length of BD. We have to find the length of BD. So again, I have to use the distance formula. So let's subtract our x's. 5 minus negative 7. 5 minus negative 7 squared plus 1 minus negative 5. 1 minus negative 5 squared. Well, 5 plus 7 is what? That's 12. That gives me 12 squared. And 1 plus 5 is? That gives me 6 squared. Let's see. 12 squared is 144. And 6 squared is 36. And when I add those together, I get the square root of 180. Good job. The square root of 180. Check my work. Booyah. Thumbs up. We're doing great. Okay. Are the diagonals congruent? Are those the same measure? Heck no. That just tells you that this is not a rectangle. That's all it tells you. You don't have a rectangle. Go to the next one. Now we're going to try to find the midpoint of the diagonals. The midpoint of the diagonals. So I'm going to draw my diagonals in there again. So I like to see them. And I'm trying to find the midpoint. Remember that the midpoint, you add the x's, divide by 2, add the y's, divide by 2. So the midpoint of A to C, negative 5 plus 3, divided by 2, comma, the x's, 0 minus 4, divide by 2. Well, negative 5 plus 3 is what? Well, that's negative 2. So I have negative 2 over 2. 0 minus 4 is negative 4 over 2. Can I simplify that? Yes, to what? Negative 1 and negative 2. So the midpoint of AC, which has to be written as an ordered pair, is negative 1 comma negative 2. You've got to put it in a parenthesis. It's an ordered pair. Now let's find the midpoint of BD. Let's find the midpoint of BD. So I'm going to add the x's. 5 plus negative 7 over 2. Add the y's. 1 plus a negative 5 over 2. Let's see. 5 and negative 7 give me negative 2. 1 and negative 5 give me negative 4 over 2. Well, that's the same thing we had before. That reduces to negative 1 comma negative 2. So my midpoint of diagonal BD is also parenthesis negative 1 comma negative 2, close parenthesis. So it's going to ask you, does that mean that the diagonals bisect each other? Do they have the same midpoint? Yes, they do bisect each other. So that means that this is a parallelogram. Okay. So this figure is a what? It's only a parallelogram. It's not a rectangle because the diagonals were not congruent. And it can't be a square without being a rectangle. And it can't be a, well, we don't really work on rhombuses, but it's not a rhombus either. Okay? So this figure is a parallelogram. Did we all get that? Okay. So you have slides 9 through 18 to complete in class. You will need a dry erase board or a piece of paper. You absolutely will need a dry erase board or a piece of paper.